Welcome back. Hononegah Honors, Algebra 2, Section 10.3, two-way tables and probability. A two-way table displays the same information as a Venn diagram. In a two-way table, one category is represented by the rows and the other category is represented by the columns. Each entry is referred to as a joint frequency. The sum of each row and each column is actually called a marginal frequency. So when you're actually putting the data in, so in this case, freshmen attending or freshmen not attending. And then the next class, sophomores attending and sophomores not attending. So when you start adding these up, like how many attended, how many did not attend, how many freshmen, how many sophomores. So when you start adding up each one of those columns, those are referred to as marginal frequencies. There are 16 juniors and 24 seniors in a debate team. So when I'm looking at this team total, there are 16 juniors total and 24 seniors total on the debate team. 7 juniors and 19 seniors qualify. So 7 juniors and 19 seniors qualify. Organize this information in a two-way table and then find and interpret the marginal frequencies. So how many juniors did not qualify? Well, that means if there's 16 total juniors and 7 qualified, 9 did not. And if 19 seniors qualified of the 24 on the debate team, 5 didn't qualify. So when I start totaling this up, how many qualified? 26. How many did not qualify? 14. And then you start adding up the grand total number of people then that are in the debate team is 40 total people. So and then you can ask a lot of questions. When you have this type of stuff, then you can start doing the probability that a junior that qualified. So again, these type of tables lead into more probability type questions that you can ask that goes along with a two-way table. Joint relative frequency is the ratio of the frequency is not in the total row or the total column or the total number. So the joint relative frequency is the ratio of the frequency. Marginal relative frequency is the sum of the joint frequencies. A conditional relative frequency is the ratio of the joint relative frequency to the marginal. You can find the conditional relative frequency using the row total or the column total of a two-way table. So explaining that a little bit better, if I want a joint relative frequency, that's each cell in a two-way table compared to the total. If I want a marginal relative frequency, that is the sum of those, again, to the total. And the conditional relative frequency is the ratio of a joint to a marginal. So that is a conditional relative frequency based on two different scenarios. So here we go. Use the debate competition information. So going back a couple of slides here, I believe, I will go back here, 7/19/26. I wish they would have go ahead and put that in. And then I believe, I don't want to make an assumption here, 16/24/40. And then I can fill in the rest here. We're talking about 9, 5, and 14. All right. Use the debate competition information to make a two-way table that shows the joint and marginal relative frequencies. So that's the information. I should have copied and pasted that. And then what they want me to do is I want to compare each one of these divided by the total. So basically, I'm just going to pull out a calculator here, and I'm going to get 7 out of 40. So this is juniors that qualified out of the total. So that is when they talk about a joint relative frequency. It's how many in a particular cell out of the total. So I'm going to erase that one, and I'm going to put 0.175 as a decimal. And so the next one, 19 divided by 40. So 0.475. So 9 out of 40. 0.225. And then 5 out of 40. 0.125. Now, here's what's going to happen. I can either take 16 out of 40. So 16 divided by 40. which is 0.4, or I could add up the two joint relative frequencies, and it would add up to the marginal relative frequency. So this one, I'm going to do it by adding. So 0.475, 0.125 would get me 0.6. And so again, that gives me a grand total of 1 or 100%. So going the other way, I'm going to add this instead of taking the number there. So 0.65, which makes this 0.35. So that is when you start talking about joint and marginal relative frequencies. And so the next one, the debate competition information example one, to make a two-way table that shows the conditional relative frequencies. So the conditional one is, again, based on the row total. So they're telling you where to do your basis. So I'm going to have to go back to the previous slide. And what this means is the number that qualified out of the total number of juniors, because we're basing it on the row. So in that particular cell, you're going to take 0.175 divided by 0.40. And so that's the answer to the conditional relative frequency. It's a condition 0.175 divided by 0.4, and I'm going to get 0.4375. And so you're going to do the same thing for each one of those. So 0.225 divided by 0.4 and get 0.5625. So I'm doing this, again, based on rows. So 0.475 qualifying seniors out of the total number of seniors. So everything is based out of the total number of seniors now instead. So 0.475 divided by 0.6. And so I end up getting 0.792 or 7917. And then the last one, 0.125 divided by 0.6 again, and I'm going to get 20.208. So again, you're basing this out of the total number of seniors instead of basing this out of the total number of people. So to be honest with you, going all the way back here, you could also do like 7 divided by 16. So it's a question of how many juniors, what percentage of juniors qualified, or what percentage of juniors did not qualify. And that's what the conditional relative frequency gets you, is the percent of juniors only that did not qualify. The store surveys customers at different ages. The survey asks whether or not you would like to see the store expand its toy department. The results given a joint relative frequencies are shown. What is the probability that a randomly selected customer whose age is between 10 and 20? So now you remember, we're talking about a customer that has to be between 10 and 20 would not like to see the toy department expand. So this is a conditional frequency, because the number of people between 10 and 20, if I added this up, we're talking about 0.23, of which what would not like to see the toy expand. So what people said no, 0.17. So 0.17 out of the 0.23 is a 73.9%. Okay, so it's what is the probability? It's 73.9% chance that a randomly selected customer whose age is between 10 and 20, so that is the key, would not like to see the toy department expand. What is the probability that a randomly selected customer who would like to see the toy department expand? So now I want the yes people. So randomly selecting one of the yes people, 0.27, 0.06, and 0.23. So we're talking about 0.56. What is probably the randomly selected customer who would like to see the toy department expand is younger than 10? So now we're talking 0.27 And so, again, you're taking all the yeses and then looking for the yeses that are younger than 10. So you're talking about 0.27 divided by 0.56. And so there's a 48.2% chance if I took the yes people only and I ended up getting somebody below 10. A manager is assessing the 3 employees in order to offer them a promotion. Over the period of time, the manager records whether or not an employee meets or exceeds the expectations. The table shows the manager's results. Which employee should be offered the position? So now Joy has done it 9 times, exceeded, and then 6 times just met. Elena, 12 times exceeded and 8 times just met. And then Sam, 11 times met or exceeded and 7 met. And so when you're looking at this, you might say, well, I would give it to Elena. She has exceeded my expectations way more times. Well, that isn't necessarily true because Elena's also has more times in which she's been evaluated. So when you're looking at Joy, it's 9 exceeds out of a grand total of 15 evaluations. Elena is 12 exceeds out of a grand total of 20. And then Sam has 11 exceeds out of a grand total of 18 evaluations. So find each one of them exceeds versus evaluations. So 9 out of 15 has a 60% exceeds to evaluations. Elena also has a 60% exceeds to evaluation. And so then when I look at Sam, he's got a 61.1% exceeds to evaluation, and therefore Sam is the person who should be offered the promotion because he has the best chance of exceeding expectations based on those evaluations. This one can be a little bit confusing. I know there's a couple times I had to hit pause because I wanted to make sure of something before I said it. So I hope the video comes out okay. If you do have any questions, please make sure you talk to your teacher. Your homework assignment is on page 558. And good luck.